Today we learn how to perform NI myDAQ simulation for half-wave rectifier, full-wave rectifier, and bridge rectifier. For that, open new instead of blank, select NI myDAQ design, create. So you are getting a interface like this. This is NI myDAQ design simulation. Okay, place resistor of 22 kilo ohms and a diode 1N 4007 G use. So we connect the signal from the function generator by the analog output channel 0, that is AO0, and the other end is connected to, let's just other end is connected to the diode cathode. Okay, and we make the ground to black color, and instead of visualizing the observing the signal in the CRO, I use the analog input channel 0 plus and the analog input channel 1 plus. The A channel 0 plus is for the input signal, and A 1 plus channel for the output signal. To differentiate, I use the net color for the output signal is blue, and the input signal is red color. Now connect A0 minus to ground. Similarly, A plus is also, sorry, A1 minus is also ground. For understanding purpose, on the line, on the wires, I am mentioning the connection pins AI1 plus and AI0 plus. This is AI0 plus, and this is AI0. Okay, and here I use the pins control T, AI, AGND, AI 0 minus, AI 1 minus. So once the connections is over, I double click the function generator. I am double clicking the function generator. See, this is a function generator. I select the frequency to 1 kilohertz and amplitude is peak to peak amplitude is 10 volts peak to peak. This is the maximum voltage we can get from the myDAQ and double click on the oscilloscope. Okay, um, channel 0 is AI0, channel 1 is connected to AI1. So please enable channel 0. By default, channel 0 is enabled. So for observing the output signal, channel 1 is also enabled. And set the time base is 500 microseconds. The thumb rule is the time base of this CRO is half of the time period of the input signal. Since the input signal is 1 kilohertz, the time period is 1 millisecond. Half of that is 500 microseconds. So you can easily visualize that signal. Similarly, set to scale volts per division to 2 volts, both for channel 0 as well as channel 1. Now click on the graph properties and background color change to white and the plot's thickness. To change the plot thickness, you select the channel 0 real and default thickness is thinner. That's why I changed to thick one. And similarly, channel 1, I put the same colors. I use the same colors, the default colors. Whereas for channel 0, the thickness is I changed and color is changed to red color. And channel 1 is color is also changed to blue color. Blue or black, whatever it. I used to use the blue color. Okay. Now run the simulation. Okay. Stop the simulation. This is my input signal. See, which is 2 volts, 2.5 centimeters into 5 volts peak. Peak to peak is 10 volts. Where the output signal is almost peak voltage is 2.5 volt. Sorry, it is 5 volts. Almost it is 5 volts. So in this way, you can observe the input and output of a half wave rectifier using NI myDAQ simulation.